When you're ready.
Okay. What is water hardness and fluoride concentrations in water at a high school? My question development. My initial question was, can lignin be used to grow tissue? And my current question is, what are the hardness and fluoride concentrations in the water at my school? My research question changed drastically. This is because as I was researching about lignin, I found it to be difficult to understand and difficult to get a hold of. So I decided to change it and start brainstorming with some classmates about water and the different types of it. The topic of water quality came up and it piqued my interest. I started researching different types of water, wondering why some tasted better than others. As I further researched what elements were in the water, the more I got interested. I decided that I wanted to look into the school's water if it contained fluoride, along with how hard the water was. My hypothesis. I hypothesized that there would be a significant amount of fluoride in the school's water, and I also thought that the water would be fairly hard. Background. So water quality, hard and soft water, and the effects of fluoride. What is it? To have safe drinking water, there has been specific criteria put into place along with regulations that have to be followed. Drinking water has certain desirable traits just like it has undesirable traits. There are 7 categories that they are distributed into. Color is the first one, which is because the presence of dissolved organic matter in peaty soils or the mineral salts of iron and manganese. Suspended matter is a fine mineral and plant that isn't able to settle out of a solution under prevailing conditions. Turbidity is another one. It means the measure of the clarity or transparency of the water. Cloudiness can be caused by numerous factors, such as fine particles in suspension, high bacteria concentrations, or even fine bubbles due to the over-aeration of water. Over-aeration wastes energy and can negatively affect process performance. Most water treatment plants will operate theirs at certain aeration zones. Pathogens are another unwanted component in water. According to N.F. Gray, these viruses, bacteria, protozoa, or other are types of pathogenic organisms that can adversely affect the health of the consumer. They can arise from animal or human waste, contaminating the water resource. Hardness, if it's excessive or if it's extremely low, is both not desired. Excessive hardness arises from groundwater resources, whereas soft waters are characteristic of some upland catchments. Taste and odor are also important factors in drinking water. Unpleasant taste and odor are due to a variety of factors like contamination by wastewaters, excessive concentration of certain chemicals such as iron, manganese, or aluminum, decaying vegetation, stagnant conditions due to a lack of oxygen in water, or the presence of certain algae. The last is harmful chemicals. There is a wide range of toxic and harmful organic and inorganic compounds that can occur in water resources. These are absorbed from soil or occur due to contamination from sewage or industrial wastewater. With these categories, people are able to get safe drinking water. Now, the urban water cycle. It takes into account stormwater moving across hard landscapes where it cannot be absorbed into the ground. Groundwater is then pumped into the surface for use in homes and businesses, and wastewater travels to water treatment plants. The overall goal of water treatment is to produce consistent and a continuous supply of water that is chemically and bacteriologically pleasing. Bacteriologically pleasing. Water treatment also has criteria that consist of another 7 points it must follow. According to Gray, from drinking water quality, the water must be palatable, meaning it has no unpleasant taste. It has to be safe, and it cannot contain any pathogenic organisms or chemical that could be harmful to the consumer. It needs to be clear. The water needs to be free from suspended matter and turbidity. It also has to be colorless and odorless and it has to be aesthetic to drink. Reasonably soft means that it has to allow consumers to wash clothes themselves and wash dishes, clothes, and themselves without excessive use of soaps or detergents. And it has to be non-corrosive, so the water should not be corrosive to pipework or encourage the leaching of metals from pipes or tanks. Finally, it must be low in organic content. If the water has high organic content, it will encourage unwanted biological growth in pipes or storage tanks, which can then proceed to affect the quality of the water supplied. Hardness. Hard water is basically the amount of dissolved calcium and magnesium in water, whereas soft water means the water does not have dissolved salts of metals like calcium, iron, or magnesium. But it also does depend on the geology of the area that the water has been in contact with. Typically, surface waters are softer than groundwater. This is because the groundwater is naturally occurring from the withering of limestone, sedimentary rock, and calcium-bearing minerals. In the US, total dissolved solids are used in place of hardness. This is because it is a broader classification than hardness, and that measures the total amount of inorganic salts and a small amount of organic matter present. Total dissolved solids is the measure of the total concentration of ions in water. Soft waters are not the best for health reasons, and to help protect pipes. Soft waters enhance the corrosion of copper and lead pipes. They are harsher than hard waters. According to Drinking Water Quality, there was a study conducted in the UK, and it reported that in 1982, mortality from cardiovascular disease was closely associated with water hardness. The mortality decreased as the hardness increased. It was present for strokes, ischemic heart disease, but not for non-cardiovascular disease. So, what are the effects of fluoride? What does fluoride do to humans' overall health? Fluoride strengthens tooth enamel, prevents caries, tooth decay, tooth loss, and cavities. It has so many benefits, so why not put it in the drinking water? It has so many benefits, so why not put it in drinking water so it can help protect people's teeth? That's where it can get a little tricky on if it's actually good for people's health. There are many countries that artificially fluoridate drinking water for reasons to protect the health of humans' teeth. A few of these countries are Brazil, the United States, and the United Kingdom. Research done by Bashash et al. 2017 found that children in Mexico had a lower intelligence quotient because their mothers had consumed more fluoride while they were pregnant. A very similar outcome was found by Green et al. In 2019 in regards to Canadian children and their mothers drinking fluoridated water throughout pregnancy. A quote from Igborn and Oman 2021 found an increase of 1 milligram in fluoride was associated with a decrease in almost 4 intelligence quotient points. The overall association was driven by boys. These results have intensified the debate among scholars regarding whether fluoride is neurotoxic. There is more research being done about fluoride levels because the World Health Organization levels should not exceed 1.5 milligrams a liter in drinking water. There have been reports of negative associations with cognitive development for levels that are below the recommended amount of fluoride. Molinex et al. 1955 did a study that exposed rats to fluorides through fluoridation in drinking water. This study found that brain tissue can store fluoride and it passes through the blood-brain barrier. It ended up finding that higher concentrations of fluoride in the brain affected the behavior and induced behavioral changes. My testing. What I did to test my hypothesis was obtain a water kit. This kit allowed me to measure the concentration of fluoride while also providing water hardness. The first step was to obtain the water sample from school. Then I got the rest of the materials needed that included the testing strips and the color guide. To actually do the experiment, there needed to be a clean and clear space. From there, the water testing strip was dipped into the sample for 15 seconds, then pulled out on a dry paper towel. After waiting 15 seconds, the colors on the strip changed, signifying the results were ready. Here you can see the color guide that I followed, and then the test is just from Verify, and it can test for 16 different chemicals, but I just did water hardness and fluoride. My limitations. There are quite a few limitations when it came to using test strips for this experiment. One of the main drawbacks of using a test kit is that it's not as precise as other methods. The kit comes with a chart that has colors that correspond with the amount of chemical that may appear in the water. Because of this, the numbers are general and not as precise as one would like. For example, there could be a very small trace of lead in the water sample, but the test kit wouldn't pick it up. Another limiting factor was that the testing kit may not be extremely accurate for differing reasons, for different factors. My data. While not all my data aligned with my hypothesis, I learned a lot from it. With the pictures on the screen, you can see the result from the test strips. In both pictures, I have put an unused test strip, the top and both of them are unused ones, next to the test strip that was used for the experiment. The kit measures the chemicals in ppm, meaning parts per million. The water hardness ended up being the darkest purple the test measured, which turned out to be 425 ppm. And here you can see the original color on the test is blue, and then it's kind of hard to see, but that is the darkest shade, signifying it is 425 ppm, and it is in the very hard region, which is not great. While unfortunately fluoride measured at 0 ppm, over here, the fluoride, that was the original color of the test, which is just red, and it stayed the same, signifying there wasn't any fluoride. And then my conclusion. I initially wanted there to be a significant amount of fluoride in the school's water, and that the water was very hard. I had high hopes that the fluoride concentration would be high because I thought it would bring more interesting results to the table. Instead, I found that there was zero trace of fluoride in the water sample I acquired from school. But I did find the hardness, and that shocked me a bit because I didn't think the school's water would be as hard as it is. The water being 425 ppm in the very hard section was shocking. What my research means is that you may not know what's actually in the water that comes out of the faucet and how it can affect the human body.
I'll add a soundtrack there. Big applause track. How did the choices you made when designing or implementing your research method impact your research process?
Deciding to use a test kit to complete my experiment impacted my research in a few ways. The most prominent being that the results weren't as precise as I would have liked them to be.
Okay. What are the real-world implications or consequences related to your findings?
The results of my study can be used as a way of letting people know that just because the water is coming out of your faucet in your home or anywhere, it might not be as safe as you think and good for your body.
Okay. If you could revisit the research process, what would you do differently and why?
I would talk to more than one chemistry teacher and try and find a better method and procedure to get more accurate and precise data.
Okay. All right. Another round of applause.